Hello, everyone. I put together a little video in case you missed class this week, just because this topic is really tough to learn on your own. So I'm just going to kind of go through what I did in class. Hey, first of all, we did good things. We always do good things. My good thing is I bought a house. So I'm really excited about that because I'm going to have a place to live. All right. Hey, one thing you need to do is get out your green sheet with all your learning targets. We spent some time updating that, and I gave some notes specifically around that. So if you go into Schoology, I've uploaded it. It's called like Green Sheet Learning Targets Chapter 1. You're going to want to find your green sheet and go ahead and upload, or not upload. You want to go ahead and copy down what I put on there. All right. Now the next thing you need to do is you got to find this little packet. There's me peeking behind it. Because we did a lot of work in this packet. So go ahead and find that packet and make sure that you have it. Let me make this bigger so you can actually see what I'm doing. All right, so find that packet because you're going to need it as you go through this stuff. All right, so one of the pre-work from the week previous was to go ahead and take this shoe data. This is the 2G data from my students, and put it into Staplet and make these three graphs. That would be a dot plot, which is this one up here, a histogram, which is this one down here, and then a stem plot or stem and leaf plot, which is this guy over here. Okay, so that would be part 3 of your handout, question 3. If you haven't done that, go back to the video that shows you how to do that, go into Staplet and do that. So question 4 is going to ask you to look at the distribution and do some describing. So this is what we call the SOCs or SOC V. This last thing, the variability, could be either variability or it could be spread. So the first thing I'm going to look at is shape. Now, if you look at the dot plot, oh, and by the way, you really should stop the video and go back and take the notes from your green sheet because I'm going to be referencing some of that material in specific shape, outlier, center, and variability. So stop the video and go back and do that, then come back and watch this. It'll make a lot more sense. So one of the things we talked about in class is that this data in specific, the 2G data, you could kind of argue the shape is 2 different ways. So if you looked at just this dot plot right here, it's somewhat symmetric because you've got a little bit of data on the left, you got some data in the middle, you got some data on the right. You know, looking at just at this dot plot, you could say it's mostly symmetric because most of the data is sort of distributed evenly on all parts. Now, if you look at the stem and leaf plot and the histogram, I want to move, I can just pull back. Okay, cool. So here's the histogram. It's slightly skewed to the right because you can see like I've got a bunch of data here on the left and then it sort of tails down to the right. So it's skewed to the right. I'd say slightly skewed to the right. You could also look at this right here, the stem plot, and you can't tell it's skewed right, but if I take this shape and I rotate on its side so that the 0, 1, 2, 3 is on the bottom. Now you can see I've got most of my data here on the left and it's tailing to the right a little bit. And that would be skewed to the right. So that both those answers you could use and they would both be fine. I think technically I said moderately skewed to the right. I mean, if you put slightly or moderately, I mean, I think you're both okay. One of the things you have to get used to in statistics is this is not algebra 2 where at the end we all agree that x equals 32. At the end there is like a little bit of room for interpretation in terms of like is it skewed left or right. Especially real life data. It's rare for real life data to come out like the data you would see in a textbook. Okay, so outliers, there are 2 outliers. We got 2 students in 2G who have 25 shoes. I don't know where they store those shoes, but there's some shoes there. Those are my outliers. It's pretty far from the rest of the data. Center is just what is the mean and the median number of shoes. Now you are welcome to, for the mean, add all these numbers up and then divide by how many there are. And for the median, you can put them all in order and cross them out. And actually, there's 2 numbers in the middle, 8 and 14. And you got to find the middle of that, which is 11. Or Staplet actually gives you the mean and median. So if you type this data into Staplet, there's a little box at the bottom and it'll tell you, hey, the mean is this and the median is that. Range is just talking, the ranges are how we're going to talk about variability or spread. So The range here is 2 to 25, the smallest to the largest, which is a difference of 23 shoes. So that's your variability. So that's the answer for 4. Hey, question 5 just talks about which data display do you prefer. It's kind of personal preference. I do like the histogram and the stem plot just because it gives me a pretty good picture of the skew left, right, or if it's symmetric. A lot of kids like the dot plot because all the data is sitting there. There's nothing hidden. You can see all the numbers at once. And you can say the same thing about the stem plot. All the data is right here. Okay, so that is number 5 in your packet. Turn the page. So the next thing is number 6. The first thing we asked you in 6 was to go ahead and add this teacher shoe data, how many shoes teachers owned, into Statlet. Okay, now it says one quantitative variable, multiple groups. So I'll just start showing you how that works. So one quantitative variable, multiple groups. I click this one right here. And I'll say number of shoes. And for the first name, I will put teachers. And then I will go ahead and start typing in all this data. 15 space 8. I'm looking at the worksheet now. /10 /29. Not slash, space, et cetera, et cetera. And then for the students, I'll go back to that page previous with the 2G and 3R, and I'll go ahead and start putting 2G's data in, 2, 14, 25, 15, et cetera. So you just type that in, hit begin analysis, and it's going to give you your graphs. So you should go ahead and try that. Make sure you can get to the right click links and get it all graphed and looks nice. But here's what your graphs should look like, okay? So we got, there we go. We got our double stem leaf plot here. We got our double dot plot here and our double histogram, one for the teachers and one for the students. So student, teacher, student, teacher. In this case, it looks like I typed the student data in first and the teacher data in second. All right, so we're going to compare these two data sets, which is, if you go back to your packet, you got to pick one of these and put it in for number 8. If I were you, I'd go ahead and do all of them. And then we got to look at 9. We got to compare the distribution. So here is what I did for 9. I put these words in red. They're words that, as teachers, we're looking for when you're comparing these distributions. So the shape, if I look at the teacher shoe data, it's slightly more skewed to the right than the student data. Because if you look, you can see like there's this big group of data here on the left, and then this long tail, if this thing gets out of my way, this long tail to the right. So here in the student data, it's a little more uniform. So I did mention that, like student data is slightly more uniform than the teacher data because it's I've got like 1, 2, 3 bars that are all the same. While the teacher data, I've only got these bars are the same here, but the rest of them, like there's this big group of data here. So, I said that the teacher data is slightly more skewed to the right. If you said moderately more skewed to the right, that's fine with me. Again, real life data is hardly ever going to be like the data you see in a textbook. It's going to be a tiny bit messy. You could, if you wanted to, look at you can see it a little bit here in the stem plot again. You've got like this big group of student data right here, and then the teacher data's got this. So you could argue this over here that the student data is actually more skewed to the right because you have this big group of data here. Again, in stats, you can kind of argue it either way based on the graph you're looking at, and you would still be correct. It's just the nature of like a different graph sometimes gives you a different shape. Okay. Okay, so outlier. I just mentioned that the teacher data has a shoe outlier of 35 shoes because you've got one teacher who has a lot of shoes. And then I said that's greater than the student data outlier, which is only 25 shoes. Because like here's the teacher, here's our outlier 35, here's the 25. We don't really consider these 2 points outliers. I get that they're like far away from other data points, but when we talk about outliers, it's like, are there any points really high up or really low down that are far from the rest of the data? And so this is the point that's really large, that's far from the most of the data, and these are the points that are really large, far from the rest of the data. I wouldn't consider these two necessarily outliers. Censor. So again, I just found the mean and median using Stapplet. You type all that stuff in, it just gives it to you. But you notice I mentioned the mean and median, and I also forgot to put this in red. They're greater than the corresponding mean and median for the student data. So it's not enough just to say what they are. You also want to compare them, like, is one more than the other? And we'll talk a little bit more next week about, okay, well, should we use the mean? Should we use the median? Does it matter? I mean, for now, we want to talk about both of those. And then we can maybe whittle down if like one's more appropriate than the other to describe the data or to compare data sets. And then spread/variability, that's just talking about range for now. The teacher data is a greater spread than the student data. I just found the range of the teacher data, it's 29. I just took that 35, the highest, minus 6, the lowest, that's the lowest data, and subtracted those, and I got 29. And then I said that's a greater than the student data, whose range is only 23. So that's number 9 on your handout. And that's as far as we got in class. So kind of update your green sheet, update your yellow packet. And if there's anything you have questions about, we did talk a little bit about like how you even read this. It's a little confusing because it's double-sided. Maybe you can send me an email, or you can check in at office hours about if you're a little confused about some of these. But this gives you a general idea of like how do we describe distributions, which is what I'm doing here. I'm just looking at these graphs and describing them here, number 4. And then how do I compare distributions, which is what I'm doing here in 9. And that should get you through some of the remote work that we've posted for this week to look at distributions. Okay? All right.